Alright, Gregory Mahalik, FTH 202. Today is early Monday, the 26th. We're getting this second half of the assignment done here at home. And while we're on the road, we're going to knock out the first half of it and get the video all spliced together. Get to go to Anniston, Alabama this week. About a 10-hour drive from East Texas. Got picked for the CMP Advanced Maintenance course for them $1 grand. Entered that lotto system and got picked. So it's kind of exciting. Looking forward to it. Hope this 10 hours drive goes by fast because tomorrow morning we'll wake up bright and early and we get to the class, do some instruction. Wednesday we'll roll into more instruction, finish the build of the rifle. Thursday we'll test fire and I turn around and I drive back home, swap vehicles out real quick and repack, turn around and go on base for 3 days. Go to reserves and get these guys ready for JRTC. Luckily I ain't got to go. Being a business owner, too much money losing it for a month, so I get saved from the JRTC hell. Still got to do my 2-week annual training, but at least with that, I can break it up over here and there and schedule in between jobs. I don't lose any money. Got our course material back here over us. I definitely will be putting on the SDI pages on the M1 Grand stuff and on my business YouTube and stuff like that. So if you're curious how it goes, definitely take a look. Hopefully it's going to be a really good class. Looking forward to it, and hopefully I'm going to learn a lot. Well, let's get on the course material for the assignment. We've got our cleaning rod here with our jag. We've got our cleaning patch right here that we're going to use. We already test fit, marked a hole in the patch of where I need it to be in order for it to successfully push through the barrel. We're going to mark our flag at 12 o'clock. We've got a zip tie, as you can see on my face, to identify the rotation. We'll stick this in the barrel a little bit. Lock this vise down. Turn it the right direction. There we go. So we're right here at 12 o'clock. We'll push her in till it rotates, and we are going to mark this a second time. Got our mark on there. Continue pushing. Pull our cleaning patch off. Pull it out. We're going to take a ruler and we're going to now measure our markings. I'm going to pause this, flip the camera around, and we'll show you the results. As you see, we're just a hair shy of 3 inch. Our other markers right here on the back of the jag. I did offset the ruler as on this side it is not true. So we're going to use that line mark here. Do a little math, we'll show the results, we'll compare them with Taurus's website on what the 856 rifling measurement should be. I did redo the test as I was a little off, and you can determine here we got our line on the 1, and right here we're relatively really close to the 3, just a fat Sharpie. But we come over to our computer, we verify the twist rate is a 1 in 16.5. And just to show, here's our Taurus 856. So with measurement, the way we're doing it with our zip tie, piece of tape, same reference material, cleaning jag, and the patch, a little room for error, especially on the shortness of this barrel. But this gives us overall a really close way to determine, and then we can reference it with manufacturer specifications. And that concludes our measuring the twist rate. Gregory Mahalik, FTH 202, March the 3rd, Sunday evening. Severely sleep deprived. Been in the field doing stuff on base for the last 3 days. Before the week, as we kind of mentioned in the other part of this video, we were at the CMP program for M1 Grand AMC class. Forgot to take the Taurus with me and got out there and realized I forgot it in the house. So therefore the work didn't continue. We're home now. We're going to get this knocked out. We're going to grind through this first part of the video, but when I splice it will be the second part of the video. Just makes it a little bit easier. But we're going to show the firearm is free and clear. We can see the side plates off it currently. This one need to give me a little bit of difficulty here with the side plate being off to unlock it. There we go. So we can see the 6 chambers are empty, as well as we can see that there is no brass in or bullets stuck into the internal barrel of the firearm. We got 4 parts we got to identify on this and they go over how they function on the cycle operations. If you remove the components, how that can result in a failure to fire, failure to eject, failure to cock, and so forth in the firearm, and what are the repercussions of that part, or to become damaged, broken, or missing. So we have the hand. We have the double action sear right here. The additional part of the sear is right hard here. It's kind of hard to see. It's on the trigger. We have the hammer, of course, and then we have our cylinder stop, which is this component here that curves, and it sits right below the cylinder and actually rides in these notches on the cylinder, which keeps it from rotating. So since we just talked about the cylinder stop, that is directly involved in the stoppage of the cylinder. So if we were to lose that cylinder stop in this firearm, this cylinder would just freely rotate and could potentially come off and have an issue with the timing of it, resulting in a no fire situation. So next we have our sear. If we look, we have our sear right back in the trigger. As we start to pull the trigger, the sear will engage the double action sear, starting the cocking phase of the firearm, moving this hammer to the rear. Eventually, as we cock, they will disengage, allowing the hammer to fall and fire the firearm. But the sear is directly in relation to the cocking phase of the firearm. Without the sear, it's going to be hard to cock the firearm. Of course, we could cock it by hand. You need to stay put. But we would have a single action revolver, and if we wanted a single action revolver, we would buy a single action revolver. So kind of working our way up and around, we go into the hammer. If we lose the hammer, it's kind of hard to fire the firearm, because as the hammer falls, we will contact the transfer bar, hitting the firing pin, resulting in the firing pin falling forward, hitting the primer, causing the round to go off. So if we lose the hammer, or something breaks into the hammer or the sear, we can no longer cock or fire the firearm. Therefore, the firearm is then rendered useless. Moving next into the hand right here, as we operate in single action mode to cock, or if we go to double action, you can see that the hand both times rides up. The hand is responsible for cocking or cylinder rotation of the firearm. If we lose a hand, the cylinder then will not rotate, resulting in us dropping the hammer on an empty chamber, or if it's a loaded chamber, we will fire once. We go to shoot again, the cylinder will not rotate, therefore resulting on us firing on an empty chamber. So kind of in summary, the components that we've identified, the 4 components, if they were to fail, it's going to result in failure to cock, failure to fires. We can result in a failure to lock. It can even kind of roll into a failure to unlock as well, since we're not going to unlock off that empty chamber and rotate it onto a loaded chamber. Not really going to result in a failure to eject, because we have our bolt on the side or our cylinder release to then eject our spent casings or loaded casings, as well as we will not have a failure to eject, because the cylinder is manually ejected by the user of the firearm when we open that cylinder. That can complete sleep issues. That concludes module 3 for this week. Get this video spliced together with the other one. Gotta get it submitted, and we're gonna get so much needed rest before we gotta get out on the water tomorrow and put out some herbicides and clean some ponds. So sorry for the kind of rambling, a little bit of this, but we got it done, got it turned in.